Now we are going to discuss the comparison between two sinusoidal functions. So for that commonly we are using two terminology, that is called lagging and leading. So again, try to understand the definition of these two terms. So in order to understand the definition, we are going to consider the more general expression of sinusoid. So I am going to represent now sinusoid in some more general form. So Vn sine omega t plus phi. So you can see that now our argument is omega t plus phi. So I can going to write here where omega t plus phi is the argument of function and phi is the phase. In order to compare two sinusoid, I am going to take following two function. So let us examine the two sinusoids. I am going to consider first sinusoid V1t, that is Vm sine omega t, and second sinusoid I am going to take, that is of more general form, that is represented by sine omega t plus phi. In order to understand the relation between these two sinusoids, I am going to first plot these two sinusoids on the common graph. So let us try to make this horizontal axis as Vt and again this horizontal axis as a omega t. So I am going to use different color to distinguish between Vm sin omega t and Vm sin omega t plus phi. So first plot the Vm so this is the plot of Vm sin omega t. Now I am going to plot the Vm sin omega t plus phi. So with different color. So magnitude Vm remains the same. So approximate plot will looks like this. Something like this. And basically this particular portion is nothing but phi. and this is the graph of Vm sin omega t plus phi. So from this graph it is clear that this function, that is Vm sin omega t plus phi, I have represented this by V2, and I have represented first one, that is by V1. So the starting point of V2 in the figure occurs first in time. Therefore we say, so we are going to state following statement. So the starting point of V2 in above figure occurs first in time. Therefore we say, so following two statement I am going to write. V2 leads V1 by phi. So in this course everywhere I am going to use this kind of terminology, or V1 lags V2 by phi. So these two terminology that is commonly used in this course, and if you are going to read any book, then this terminology is very common. So we are also further going to note the following. Some other terminology is also used in the literature. So that is like this: if phi that is not equal to 0, then we say that V1, and so this is V1, so just erase it, and I am going to select the same color. So this is V1 and V2 are out of phase. So if phi equal to 0, then both functions are exactly same. So we are telling that V1 and V2 both are in phase. So another statement is like that: if phi equal to 0, then we say that V1 and V2 are in phase. So basically in this course we are going to use two set of terminology. One terminology we are going to talk about leads or lag, and another terminology that is I am going to use, that is out of phase or in phase. So in order to understand the comparison, I am going to discuss one problem that is related to leading or lagging of the sinusoid. So let us discuss one numerical. So I'm going to write the problem. So our problem is like this: calculate the phase angle between, I have taken two sinusoidal voltage signal, 10 cos omega t plus 50 degree and V2t, that is 12 sin omega t minus 10 degree. Most of time we are representing phase phi in degree. So question is that state which sinusoid is leading. So in this particular problem we have two different class of sinusoid. One is cos function, another is sine function, and you can also see that here amplitude of V1 is negative, however V2 is positive. Again, in first one signal phase is positive, however phase in the second signal, that is negative, but frequency omega, that is same for the two signal V1 and V2. So before going to talk about the leading and lagging, we have to do or consider the following steps. So I am going to write same kind of thing in form of remark, because most of time I found that students are doing mistake. So a remark is like this. So a remark: two sinusoid waves whose phase are to be compared must, first point is, both be retained as sine waves or both as cosine wave. So either you can represent signal in sine wave or cosine wave. You can see that in our example one is in sine wave or cosine wave, so you have two different options. Either you can change V1 as a sine 1 or V2 as a cos 1. Second point you have to remember, that is both be retained with positive amplitudes. So you can see that in our example one is positive and another one is negative. So somehow I have to observe negative sign inside the argument part. And third one, that is important, each has the same frequency. If frequency is not same, then we are unable to do the comparison. Okay, so let us now come to the solution part. So I am going to discuss about the solution. So I am going to talk about the solution. So I can write V1, that is like this, minus 10 cos omega t plus 50 degree. So I can rewrite this same kind of V1 function as equivalent function like this, cos omega t plus 50 degree minus 180 degree. So I can write V1 as a 10 cos omega t minus 130 degree, or V1 as a 10 cos omega t plus 230 degree. So here amplitude is positive. Now after that, now we have to perform simplification on signal V2. So V2 is 12 sine omega t minus 10 degree, and since we have expressed V1 as a cosine function, so I have to change this sine function into cosine function, and this is pretty easy. So omega t minus 10 degree minus 90 degree, so basically that is 12 cos omega t minus 100 degree. Now we can further write, so we can write V2 as V2 equal to 12 cos omega t minus 130 degree plus 30 degree, or I can also at the same time I can write like this, cos omega t plus 260 degree. Therefore I can conclude that V2 aids V1 by 30 degree, or I can write that V1 lags V2 by 30 degree. So both statements are the same. So this kind of comparison is required for the further part of this course.